purpose of NEC Section 250.122d is to establish a minimum size requirement for the equipment grounding conductor in motor circuits. This requirement exists irrespective of the size of the motor overload protective device. The critical reason for this stipulation is that the equipment grounding conductor serves as a low impedance pathway for fault currents. Consequently, its size must be adequately determined to manage potential fault current levels. Table 250.122 provides the minimum size specifications for the equipment grounding conductor. These specifications correlate with the size of the overcurrent protective device. It is important to understand that scenarios may arise where the motor overload protective device has a lower rating than the overcurrent protective device. In such instances, the equipment grounding conductor size must still be calculated based on the rating of the overcurrent protective device, not the motor overload protective device. The rationale behind this is that the overcurrent protective device offers the main defense against overcurrent conditions. It is designed to trip in the event of a circuit fault. The motor overload protective device provides secondary protection against overcurrents, but it is not designed to handle fault currents directly. Consequently, to guarantee that it can safely handle potential fault current, the equipment grounding conductor must be sized according to the overcurrent protective device rating. Let's elaborate on the distinction between overcurrent and overload protection. Overcurrent protection safeguards against both overloads and short circuits or ground faults, while overload protection specifically protects against excessive current draw that can damage a motor over time. Overcurrent protective devices, like circuit breakers or fuses, are designed to trip quickly when a high current fault occurs. Overload relays, on the other hand, are intended to trip after a certain time delay, allowing for temporary motor overloads during startup or brief periods of heavy load. In the context of grounding, the equipment grounding conductor must be sized to handle the high fault currents that can occur during a short circuit or ground fault. These currents can be significantly higher than the normal operating current of the motor, and the overload relay is not designed to interrupt them. Therefore, the equipment grounding conductor must be sized based on the overcurrent protective device, which is designed to interrupt these high fault currents. To understand this better, consider a hypothetical motor circuit protected by a 20 amp circuit breaker and the motor overload relay set at 125% of the motor's full load amps. Let's assume the motor's full load amps is 10 amps, making the overload relay trip at 12.5 amps after a time delay. If a short circuit occurs in the motor, the current could quickly rise to hundreds or even thousands of amps. The 20 amp circuit breaker will trip almost instantaneously, interrupting the fault current. The equipment grounding conductor must be able to safely carry this high fault current back to the source, allowing the circuit breaker to trip and clear the fault. If the equipment grounding conductor were sized based on the 12.5 amp overload relay setting, it would likely be too small to handle the high fault current, potentially leading to overheating, damage, or even fire. This highlights the importance of adhering to NEC Section 250.122d and using Table 250.122 to determine the minimum size of the equipment grounding conductor based on the overcurrent protective device. Now, let's delve deeper into Table 250.122 and how it's used. Table 250.122 provides minimum equipment grounding conductor sizes for various overcurrent protective device ratings. The table is organized with the overcurrent protective device rating in amps listed in the left-hand column, and the corresponding minimum equipment grounding conductor size in copper or aluminum listed in the adjacent columns. For example, if the overcurrent protective device is rated at 20 amps, Table 250.122 specifies a minimum equipment grounding conductor size of 12 AWG copper or 10 AWG aluminum. It is crucial to select the correct conductor material, as the ampacity of copper and aluminum conductors differs. When using Table 250.122, it's essential to round up to the next standard size if the overcurrent protective device rating falls between two values listed in the table. For instance, if the overcurrent protective device is rated at 25 amps, you would use the values corresponding to the next high rating, which is typically 30 amps. Remember that Table 250.122 provides minimum sizes. You can always use a larger equipment grounding conductor if desired. In some cases, using a larger conductor may be necessary to reduce voltage drop or improve system performance. In addition to sizing the equipment grounding conductor, it's also important to ensure that it is properly installed and connected. The equipment grounding conductor must be securely connected to the motor frame, the metal conduit or cable armor, and the grounding electrode system. Proper bonding is essential to create a low impedance path for fault currents. Bonding involves connecting all metallic parts of the electrical system together to ensure that they are at the same potential. This helps to minimize voltage differences and reduce the risk of electric shock. It's also important to note that the NEC contains specific requirements for the type of equipment grounding conductor that can be used. For example, the NEC generally requires that equipment grounding conductors be green or bare. This helps to easily identify them and prevent them from being mistaken for other conductors. Furthermore, the NEC provides guidelines for the installation of equipment grounding conductors in different types of wiring methods, such as rigid metal conduit, electrical metallic tubing, and cable trays. Adhering to these requirements is essential to ensure the safety and effectiveness of the grounding system. Let's consider some specific scenarios to illustrate the application of NEC section 250.122d. In a situation where a motor is protected by a 15 amp circuit breaker and a motor overload relay, Table 250.122 dictates that the minimum size of the equipment grounding conductor must correspond to the 15 amp overcurrent protection. This typically results in using a 14 AWG copper conductor. If the motor is driving a critical piece of equipment and the larger equipment grounding conductor is desired to minimize voltage drop and improve system reliability, one could opt for a 12 AWG or even a 10 AWG copper conductor. However, it is crucial to remember that the 14 AWG copper conductor serves as the absolute minimum. In a different scenario, consider a larger motor protected by a 60 amp circuit breaker. Table 250.122 requires a minimum of a 10 AWG copper conductor for the equipment grounding conductor. Again, a larger conductor could be used if desired or if voltage drop calculations necessitate it. Another important consideration is the type of wiring method used. If the motor is wired using metallic conduit, the conduit itself can serve as the equipment grounding conductor, provided that it meets certain requirements outlined in the NEC. However, if the motor is wired using non-metallic conduit, a separate equipment grounding conductor must be installed. In summary, NEC section 250.122d provides a critical safety requirement for motor circuits. By ensuring that the equipment grounding conductor is properly sized, it helps to protect against electrical shock and fire hazards. Always refer to the latest edition of the NEC and consult with a qualified electrician to ensure that your electrical installations comply with all applicable codes and standards. Understanding the interplay between overcurrent protection, overload protection, and equipment grounding is essential for safe and reliable motor circuit design. Remember that the equipment grounding conductor provides a path for fault currents back to the source, allowing the overcurrent protective device to trip and clear the fault. Therefore, its size must be based on the overcurrent protective device rating, not the motor overload relay setting. Table 250.122 provides the minimum size requirements for equipment grounding conductors, and it is essential to adhere to these requirements to ensure the safety of electrical installations. Moreover, proper installation and bonding of the equipment grounding conductor are crucial for creating a low impedance path for fault currents and minimizing the risk of electric shock. By following these guidelines and consulting with qualified professionals, you can ensure that your motor circuits are properly grounded and protected. Always prioritize safety and adhere to all applicable electrical codes and standards.